strange radio signal that repeats every 3 seconds has been picked up by astronomers, and there are bursts of higher energy radiation every 0.2 seconds during this 3-second window. This signal that looks like a heartbeat is a fast radio burst that has never been seen before. What are these strange radio messages, though? Where do these short bursts of radio waves come from? Finally, and most importantly, why are these signals thought to be one of the most interesting astronomy mysteries that hasn't been answered yet? The Parkes Observatory in New South Wales, Australia, began to look into the fast radio blasts in 2007. Astronomers were looking at data from the radio telescope to see if they could find anything strange or odd. They looked for months and found nothing. A brief bout of strong radio waves that didn't last long, and then nothing. Astronomers were excited by this little spike and began to think about what might have caused it. Did this sound come from space, or did someone use their phone near the radio telescope to make it? The connection had been lost for a long time, so there was no way to find out. The spike could be seen in statistics from 2001, which is 6 years ago. That's what scientists did. They looked for more of these fast radio bursts. During that process, they found 16 more spikes that looked like fast radio bursts. But something about them didn't look good. The radio burst would only happen over 1 radio pixel if it came from space. The reason for this is that everything in the world is so far away that it looks like a bunch of tiny dots in the sky. So the burst would only take up 1 radio pixel if it came from space. However, these new signals showed up on all 13 radio pixels of the camera. Without a doubt, that came from Earth. They showed up during lunch, which was another strange thing about them. It turned out that the explosion came from a microwave. A burst of radio waves would get out of the oven when it was opened before it was turned off. This was the alert. Radio astronomers now call them perytons. They are sounds that are like fast radio bursts but come from Earth. Researchers did find 4 more bursts, though, that each took up only 1 radio frame. These were fast radio bursts from space that had nothing to do with radio sources on Earth. But how are we sure? Not only did they happen at a single radio pixel, but the shape of the signal wavefront showed signs that they were from space. Also, interferometers set a minimum distance of 10,000 km between the FRBs and Earth, which means they could not have come from Earth. Still, it wasn't enough to know that they come from space. The first thing that had to be answered was whether these signs were coming from inside the Milky Way or from somewhere else in the universe. The signal itself gave them their next clue. There was a range of frequencies in these FRB signals, which means they were broadband signals. Lower frequency radio waves are held up by the gas and dust in space as broadband radio waves pass through them. Thus, scientists can figure out how much gas these bursts have gone through by measuring the time difference between the low-frequency and high-frequency sounds. What they found was that these signals had gone through more gas than is in the solar system or even our own galaxy. That's why the FRBs were coming from places far away. The fact that these bright, point-like bursts were not all centered on the Milky Way's plane was another sign that they might have come from outside our galaxy. They showed up all over the sky instead. It wasn't enough to know that the RFES came from galaxies far away, though. We had to find out exactly what or who was causing the radio bursts. It's called ASCAP, and it was built by scientists in Australia. It is a group of 36 telescopes that work together as one big telescope. ASCAP could not only pick up the fast radio bursts, but it could also tell to within 1/100th of a degree which way they were coming from. From 100 km 62 miles, that's about the size of a coin. Astronomers use the Hubble Space Telescope and other very powerful visual telescopes to look for the galaxy or one of the FRBs came from after ASCAP found its locked direction. This is what they saw. It's not at all like the beautiful pictures of galaxies that Hubble usually sends us. This is because it is so far away that the world's strongest antennas have to be pushed to their limits just to see it. This galaxy, which is about 3.5 billion light-years away, sent the fast radio burst. In other words, the radio signal we picked up began its trip through space when life on Earth was just starting. Therefore, how could it be found from such a far away? This burst must have been caused by something very strong. It took a moment for this radio burst to have as much energy as the sun does in a year. The radio burst that happened so quickly and lasted only a millisecond could not have been bigger than 10 km across. But do we know of anything in the universe that is as powerful but smaller than a city? The answer is a neutron star, which is the dead center of a very large star and looks a lot like the nucleus of an atom. There are very few things in the world that are denser than a neutron star. Its stuff is so heavy that even a teaspoonful would weigh 5.5 trillion kg, which is 900 times the weight of the Great Pyramid of Giza. Neutron stars are one possible cause of RFES, but they are not the only one. Astronomers think that they can also be made by black holes merging with neutron stars, gamma-ray bursts, supernovas, or even blitzars, which are made-up pulsars that can quickly fall apart into black holes. Plus, when we talk about radio messages from space, how can we not think that aliens are sending them? But in 2020, scientists found the first FRB from inside the Milky Way, which made the case for neutron stars even stronger. After measuring the signal spread, it was found to have come from a galaxy magnetar in the Vulpecula constellation, which is about 30,000 light-years away. A magnetar is a neutron star with a magnetic field that is very strong, about tens of trillions of years strong. This discovery was a big step forward in radio astronomy because it proved that fast radio flashes come from stars. We have found a lot of fast radio bursts in the last 15 years, but the mystery is still not solved. Astronomers found a repeated FRB that lasted 3 seconds in July 2022. That's 1,000 times longer than most FRBs. Besides that, there are bursts of stronger radiation every 0.2 seconds during the 3-second window. Another strange thing about this sound is that it comes from a number of different places. It might be coming from a magnetar or a pulsar. It's still not clear how far this signal has gone, but it most likely came from another galaxy. It looks like its explosion is more than 1,000,000 times brighter than magnetars and pulsars in our own galaxy. The team is hoping to catch some more bursts from the unknown source of this FRB to figure out where it comes from and what might be making it. In turn, this might help us learn more about neutron stars. Please take a moment to like this video, subscribe to our channel, and click the bell button to make sure you don't miss any video. Thanks for watching.